Welcome to The Explainer. So you know that feeling when you wake up and your brain is just literally clouded with fog? Well, today we're looking at one of the most fascinating discoveries in modern neuroscience. We're talking about brain maintenance, and we're going to explore exactly how our brains wash away the day's debris.
Does the brain have its own waste clearance system? And maybe more importantly, what happens when it fails? Well, a massive new scoping review actually holds the answers to this medical mystery. It maps out this totally hidden biological network that might just be the absolute key to long-term brain health.
Section 1. The brain's hidden plumbing. How the glymphatic system works. Okay, let's dive into this.
So this plumbing system is formally known as the glymphatic system. Basically, you can think of it as a brain-wide fluid transport and waste clearance pathway. It's this vast macroscopic network centered right on the movement of cerebral spinal fluid, or CSF, and interstitial fluid. Its main job? It actively flushes out those toxic metabolic proteins that build up in our brain tissue while we're awake. It's honestly kind of like taking out the neurological trash at night.
So how does it actually pull this off? Well, the biological mechanism really boils down to three main steps. First, it's actually powered by your own pulse. Vascular pulsatility literally drives fluid through the brain with every single heartbeat. Second, specific water channels called AQP4 open up. They act kind of like microscopic valves in a process known as polarization. And finally, the CSF and interstitial fluids exchange, actively flushing that waste right out of the brain. It is an incredibly elegant system, and it's powered by nothing more than your heartbeat and these highly specialized cellular channels.
Section 2. When the system clogs, the impact of disruption. But what actually happens when this delicate system breaks down? Because when these pipes get clogged, the consequences for the brain are severe and honestly pretty urgent.
Let's look at what drives a healthy system versus what disrupts it. So a healthy glymphatic system relies heavily on deep sleep, a synchronized circadian rhythm, and really solid vascular health. But when we flip over to the disruptors, the picture gets pretty alarming. We're talking sleep deprivation, obstructive sleep apnea, and just general aging. And sleep? Sleep is absolutely crucial here. When we don't get enough deep sleep, or when conditions like apnea constantly interrupt our rest, the plumbing simply stops flushing effectively.
Section 3. Links to major diseases. The evidence landscape. This brings us to what is arguably the most crucial finding in the research. See, impaired brain clearance actually behaves as a convergent biological phenotype. That means it's not just some isolated issue. It's a shared underlying link strongly associated with the absolute heavy hitters of neurology. We're talking Alzheimer's disease, Parkinson's disease, ischemic stroke, and cerebral small vessel disease. When the brain fails to clear its waste, these devastating neurodegenerative and vascular conditions repeatedly show up in the clinical data.
And this brilliantly illustrates the real-world impact. Scientists actually measured this clearance using an imaging metric called the DTI-ALPS index. And the data here reveals a really stark difference. They found a clearance score of just 1.30 in patients with obstructive sleep apnea compared to a much healthier 1.62 in the control group. That is a massive, highly significant drop in the brain's ability to wash itself, and it's driven simply by disrupted breathing at night.
And we see a similar, alarming story when it comes to cognitive decline. To anchor this abstract concept to some hard data, the paper explicitly notes a statistically significant, quote, lower DTI-ALPS in Alzheimer's disease dementia versus controls. The p-value there is 0.009 for those keeping track. The evidence is just incredibly clear. When the plumbing fails, disease risk absolutely accelerates.
Section 4. The imaging reality check, where science stands today. Now, before we get too ahead of ourselves with the hype, we really need an objective reality check about how we actually measure this stuff in living humans right now.
While this data is super exciting, we do need to contrast what our current imaging can do versus what it can't quite do yet. Right now, glymphatic imaging is best used as an adjunctive severity or risk marker. It is not a standalone diagnostic tool yet. We're relying a lot on surrogate markers, like that DTI-ALPS index we just mentioned, which actually partly reflect white matter structure rather than pure direct fluid clearance. Moving forward, the ultimate diagnostic goal is to develop those direct clearance measurements and fully validated longitudinal endpoints. So for now, our interpretation has to remain pretty method-aware.
But make absolutely no mistake about the sheer weight of this research. This scoping review builds its evidence map from an astounding 1,042 original studies. That encompasses over 250,000 participant observations. To put that in perspective, this is a massive,
meticulously structured foundation of science.
And for those of you who really need to dig into the granular data, the complete evidence landscape is totally mapped out for you. The paper includes 592 linked references detailing everything. We're talking exact mechanisms, biomarkers, therapeutic signals, and of course, those disease associations. I highly encourage you to go explore it.
So, will fixing our brain's hidden plumbing unlock the future of neurological treatment? Honestly, as we learn more about how our brains clear waste during sleep, it's a question that could entirely reshape medicine as we know it. Thank you so much for joining me for this explainer, and keep exploring.